With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the given question is a particle is subjected to two simple harmonic motions. The first one is x1 equals to a1 sine omega t and the second one is x2 equals to a2 sine omega t plus pi by 3. Okay, omega t plus pi by 3. Now first question is we have to find the displacement at t equals to 0. The second is the maximum speed of the particle and the third one is maximum acceleration of the particle. Okay. Now what we have given is the first equation is x1 equals to a1 sine omega t. Okay, and the second equation is x2 equals to a2 sine omega t plus pi by 3. Omega t plus pi by 3. Okay, now we have to find the displacement at t equals to 0. Displacement at t equals to 0. So at t equals to 0, the x1 becomes x1 equals to a1 sine omega into 0, okay, and x2 becomes a2 sine omega 0 plus pi by 3. Okay, now this becomes a1 sine 0 and the second equation becomes a2 sine pi by 3. Okay, now as we know that sine 0 is 0, so this becomes 0. So displacement of x1 at t equals to 0 is 0 and displacement of x2 at t equals to 0 is a2 sine pi by 3, which comes out to be a root 3 by 2. Okay, now the net displacement will be given by x net equals to x1 plus x2. Okay, x1 is 0 and x2 is a root 3 by 2. x2 is a root 3 by 2, so the net displacement is a root 3 by 2. This is the net displacement. Now what is the second thing we have to find out? The second thing is maximum speed of the particle and the third thing is maximum acceleration of the particle. Okay, so we know that velocity of a particle executing simple harmonic motion is given by v equals to omega root a square minus x square. Okay, and for this to be maximum we have to put x equals to 0. Okay, so v max comes out to be a omega. Okay, now since these are two simple harmonic motions, equations of two simple harmonic motions are given, so we have to use v max equals to a net. Okay, the effective amplitude into omega, net amplitude into omega. As we can see that the phase difference between both of these given equations is pi by 3. Okay, as the phase of the second equation, as we can see that the phase of the first equation is omega t. Okay, and the phase of the second equation is omega t plus pi by 3. Okay, whatever is written in the trigonometric function inside the trigonometric function is called as phase. Okay, now the difference between phase, okay, the phase difference delta phi is given to be omega t plus pi by 3 minus omega t. Okay, so phase difference comes out to be pi by 3, and we know that the formula for resultant amplitude is given by a net equals to root over a1 square plus a2 square plus 2a1 a2 cos del phi. Okay, cos del phi, where del phi is the phase difference. Okay, so that comes out to be root over a1 square plus a2 square plus 2 times of a1 a2, and cos del phi was pi by 3, so cos pi by 3, and as we know that cos pi by 3 is 1 by 2, so that comes out to be root a1 square plus a2 square plus 2a1 a2 into 1 by 2 Okay, so that 2 cancel out and the net amplitude comes out to be a1 square plus a2 square plus a1 a2. Okay, and as we see that maximum velocity is given by a net into omega. Okay, so a net is root a1 square plus a2 square plus a1 a2, and omega is given as omega, so this omega. Okay, so this is the maximum velocity of the resultant superpositions simple harmonic motion. Okay, now we have to find out the maximum acceleration. Okay, we have to find out the maximum acceleration, and as we know that if a particle is doing simple harmonic motion, then its acceleration is given by minus omega square x. Okay, now for this to be maximum, we have to put the maximum value of x. The maximum value of x is a. Okay, so magnitude of acceleration comes out to be omega square a maximum. Okay, so this is maximum acceleration is omega square a max. So the maximum acceleration will be given by of these two simple harmonic motions is given by omega square into a net. Okay, so omega square as it is, and we know that the a net is given by root over a1 square plus a2 square plus plus a1 a2. So this is the maximum acceleration. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.